Hello, welcome to this tutorial. In this tutorial, we are going to be creating a very simple class that would accept two numbers, would accept an operation, and then perform that operation on the numbers and return value back to the user. The value that will be returned back should contain the two numbers, the operation, and the eventual result. I have a new Laravel application installed here. It's a very new application. I have my Docker system set up. I have all my settings in place. If you don't understand any of this, it's absolutely fine. This is one of the things you'll be learning in the course. We have Xdebug installed. All is working properly. Everything is installed and configured, which would then allow me to do something like this right from PHP storm. I can run my test from here. You can see my containers here. I'm currently have Nginx shut down at the moment, but I can turn it on. I had it shut down because we have nothing to do with Nginx. We're not hosting this application, but this is currently Zuri app, the thing we're working with. If I needed to run anything in the terminal, I can do it right here. So this is one of the things you'll be learning in the course, but that's not the focus of this particular tutorial. So I'm going to just keep it focused on this. This tutorial is going to be aiming to show you the proper way to do certain things that we've been doing in the past as beginners or as people who just learn on their own with no structured learning. As a software developer, the first thing you should think about is not writing the code. It is how to solve this problem. The problem we have right now is we need to accept two numbers. We need those two numbers to have an operation applied on them. We need that operation that was applied on them and the two numbers to be returned as a result back to the user in a structured manner. A structured manner essentially means that it can be trusted to remain the same every time. And I would explain what that means. It essentially means that if somebody other than you is consuming this app, they can trust your documentation that says that my result is going to be this way: number one, number two, operation, and results every time. Essentially, whatever you return would always be in this way. That's what it means to be returning it in a way that can be trusted by those that are consuming your application. So in this case, this is what we're going to be doing. We're going to be having something returned in this way. Oh, I see there is a typo here already. The first number that was used in the operation, the second number, the operation itself, and then the result of that operation that was applied on first and the second number. So apart from understanding what the problem is, we also need to not just jump right into starting to write the code. This is essentially a very simple thing. It doesn't really require us to do too much, but because the focus of this particular tutorial is helping us to understand how to do things properly, I'm going to just be doing it the way I would have normally done it if I was working on an actual project. Okay, so I've tested this works fine. I can run my tests right from PHP storm, which I don't know if I showed you already, but essentially I've have my PHP CLI set up to focus on my Docker, not just my inbuilt PHP or anyone that I've installed on my system. I have my path map already set up here, so all is fine there. I have a server set up for this particular project. I have my Docker path, even though we will never need this hosting thing that I have here, but I have it all set up. I just wanted to show you that. My test framework is probably set up. Properly set up. I'm using PHP Unit 11.5, which is I think the latest at the moment of this recording. I have my PHP Unit XML also loaded into my Docker CLI installation, so that if I do use database for my project, it will load that in when I start writing tests. And the last thing I'll probably mention here would be, if I can find it, Xdebug. Yeah, I have Send debug deactivated, and I have my own Xdebug activated here. You can play around with all of the settings if you like, but this is my own basic configuration for most of my projects, which essentially allows me to do something like this. And then I can have variable here. I can put a breakpoint here. I can then add a configuration file, which I can remove all of this, by the way. Add a debug file. Where is it? So I'm going to be doing remote debugging right now because obviously my Docker system is remote to my local system. Let's just do this. Again, this is not the focus of this course. I'm just trying to show you that I have my configuration all set up and good to go. So if I wanted to listen here, I can then say I want to debug, which will turn on my debugger and stop at my breakpoint. So all of that is all set up. You in the course you'll be learning basic information about all of this. I will walk you through how to do all of this. It's really easy to do, really straightforward most of the time anyway, depending on the complexity of your project. All right, cool. Let's stop all this. Let's just focus on the class we want to write. I'll take this out. So imagine what we are trying to do. The first thing I want to do is to use the proper name for this class. I've already called it multiplier, which essentially multiplies two numbers, but multiplier sounds a bit like it can be extended to do other things. So instead of saying multiplier of two numbers as the name of my class, I'm going to be calling it multiplier because now I can use it for more than two numbers if I wanted to extend it in the future. So let's just call it multiplier for now. The first thing I would do is to create my unit class, my unit test class. So let's go. PHP Storm allows me to do this quite easily, and then I'll say multiplier test, multiplier. I hope that's correct. All right, let's create that. There will be some errors here and there. I'll fix those. For example, I don't need this, and I just realized that I put the name somewhere wrong, so don't do like me. Anyway, multiplier test. Let's take that. Let's rename that, which is fine. Let's take this out and import again. I'm importing this. To be fair, I don't think I need to import this, but it's okay. All right, so what would be the first thing we want to do is to test the class instance exists, which is, it's something very personal to me because I do actually prefer to go nitty gritty when it comes to testing. So I don't have the class yet, so I expect this test to fail because I don't have the class yet. So let's just do it in our setup. Let's say public. It should have typed it for me, but you know, sometimes it doesn't. Anyway, it does now. Okay, so I have a setup class. I won't be doing anything with that yet, but here I'm going to say public function test class instance exists. Okay, so I'm going to also have a public variable here, call it multiplier, which I don't have yet. Remember, multiplier. I do not have this class yet. It's obvious everything is going to fail right now. So what I want to test for is that this assert instance of, yeah, so I want to assert that this variable is an instance of this class, which again seems very redundant. Multiplier is an instance of multiplier. Hey, see, this is the basic thing I just start with. This is going to fail with that error that this doesn't exist. If we import that, this is then going to fail that it's not an instance of this. So let's run the test, and obviously we'll get those errors like I mentioned. Yeah, so this is not, doesn't exist. Right, the error we are even getting is that this has not been initialized. So let's solve that error. I'll say this multiplier is resolve multiplier class. Obviously multiplier class doesn't exist, so Laravel cannot resolve it, and I expect to get that error. So let's run our test again. Now the error we're getting is that the target class does not exist. Brilliant. So we're making progress now. Now let's create the class. And I know somebody will be saying, oh, why are we doing all of this if it's just creating something to multiply two numbers? I'm just again trying to show how the proper way to do things, not just diving into creating the classes. And sometimes telling you the proper way to do things might have my own preference in it, but essentially I'm just going to be telling you what I think I know about some of these things, and then also telling you what I think, what it's generally agreeable that this should be the proper way to do it. All right. So if you want to do test-driven development, just do it, in the right way. So let's go ahead and create that class now. I have a folder here called services, and I have a multiplier folder so that I can have a proper namespace. And in there, I'll have a multiplier class. So I'll call it multiplier. Obviously, that's going to be multiplier.php, but we don't need to add PHP here because we've already mentioned that it's going to be a class, and PHP Storm would undo creating the thing for us here. Okay, so we've created the class now. There's nothing in the class at all. If I go in here, I can then import. Hopefully, oh, there's something wrong with my spelling, I think. Multiplier. There we go. My spelling was wrong. I don't know which is wrong. This one was wrong. Okay, so let's import the class now. And I'll take this out. There's something wrong with this spelling also. Multiplier. Let's change this here. There's an error here. Let's change that to say multiplier. Cool. Then it seems like there's an error here. Okay, yeah, the failure is still underlining this, which is fine. So we've imported this. We have automatically resolved. Laravel takes care of that for us. We are now testing if that resolution works, if everything is fine with that class. Okay, let's run this test again, and it fails. Very good. It says PHP Storm must start this instance argument expected must be of right. I know what the problem is now. It says must be of type string. So we're getting another error, which would help us to understand better how some of these things work. So this says the assert instance of that we're trying to run, the first argument expects to be a string, and we're giving it this. I know what the problem is. We seem to have been calling it in the wrong way. So let's switch it over and say we're asserting that this is an instance of this. So it's saying the expected and the thing that we're given. Cool. So let's try and run this again. Essentially that passes. So what we've done is to set up our test class. The test class is properly testing this. And one good thing about this entire process is that now I can do something like this. I can say run this with coverage. Coverage essentially tells me how many percentage of my class has been covered by this test. So if I go there, obviously there's no code in here, so there's nothing to be covered yet, but running with coverage in PHP Storm helps me to know how good my test and my entire class has been covered with my test. Okay, cool. So let's go back to our requirement now. Our requirement is that this class should accept two numbers. So we need to test for that. We need to say public function test class requires two numbers to work. Okay, now this will fail, so obviously we'll come here. I'm going to just do some basic constructor setup here. I'm going to say let's make it a public function. Not a function, it would be a float, I guess. Number one, number two. So I have two numbers defined in this class, but I don't have anything set in there yet. Two ways I can do this. I can set it to my constructor, or I can decide to have some parameters here that says public function set first number. Okay, that sets first number, returns self. If you don't understand this thing I'm doing, it's really straightforward. I'm going to try and explain it. This is going to return static because essentially it's returning itself. Let's duplicate this and make that for second number and set number 2. Obviously this is not going to be 1, this is going to be number, and that's going to be a float like we've already established earlier. So we're going to set that to that. I'm going to have a float here, number, have that set to that. So these methods allows us to set the first and the second number, which could be null also, by the way. Actually it shouldn't be null because we said we always need two numbers, so it should never accept null. So in the constructor, we can have two numbers here, which means when I run this instance, it's going to fail now because my instance requires two numbers to run. I'll show you now. So let's run this. That fails because it requires two numbers. It says expected. Where is it? If I can find, yeah, there we go. Dependency resolving. It expects two parameters, parameter 0 and parameter 1, to be numbers, but we don't have that number yet. So what we can do to initially solve this problem of being able to at least assert the instance of this class is to allow this to accept null. So let's say this accepts float public, okay, public. So this would accept, so this essentially is saying that the multiplier class needs two numbers. We have decided to define these two numbers in the constructor. Let's delete this. Okay, in the constructor now, this is, by the way, PHP. I think I'm writing PHP 8.3. So if you don't understand what this is, again, I'm going to be walking you through step by step each of these things in the course itself. This is a short and a brief introduction to some of the things we'll be doing in the course. Yeah, so we've said that this requires one number, although at the initial state the number can be null. That's what this is. Essentially, this is saying it can be a float or a null. It's essentially the same thing, but it's just easier and shorter to do this. Okay, number 2 can also be null. This would allow our first test to pass. So if I go back here and run this test, that passes now because we've said that, okay, multiplier can be used with or without the number because the number can in fact be null. Right, so now we need to test that class requires two numbers. So if somebody does instantiate this class without the numbers, then the class is useless because we do need those two numbers for this class to be useful. So we're trying to test that it needs those two numbers to run. All right, so how would we test for that? We're going to say this assert expect, I think it's just expect, yeah, there we go, expect exception. So if we try to use this class without you know, the two numbers that it requires, we're going to throw an exception. Okay, I don't know the exception yet, but we know we want to try an exception right there in here. Define the exception. We can write a custom exception for that, and then I'm going to say this multiplier, which is, again, remember this class is the multiplier, gets I'll just say run for now because we don't have a run method yet. The run method is supposed to be the one that runs the thing after we've set everything. So let's say public function run method, if I spell function properly, and move this over there. So this is going to take, actually we do actually need one more thing. Remember, we need the actual operation that needs to be performed on these numbers. So let's say public should, now this is what we need to decide. We need to decide if our operation is going to be a string, which again also is quite required, but because we are going to be writing text, we're going to be making it nullable also, or we're going to be setting a default value there and say our default operation is hard. If we set a default value, our test should still pass. So let's run this. That's still passing, so we're still good. If we don't set the default value, however, the test is going to fail because again it will require that particular thing. Remember, it's going to require that parameter to be able to resolve it, but we're going to be setting the default parameter here to be add. I mean the default operation to be add. So that's good. Now what this run is going to be doing is to take this number 1, this operation, and then this. Obviously this makes no sense, but that should be number 1, by the way, number 2, and then returning this value. Okay, but we need all of these things. So what we are going to be doing is to test that those things exist before we we try to use them. Okay, so let's say we can do a very simple thing. If empty, let's just use empty for now, number one, or we need both of them, so true, new exception. I don't think I want to write a custom exception, by the way, so I'm going to just say run requires both number one and number two. So I'm just going to do that for now. So if I run this test now, I'm expecting just a basic exception, by the way, because we are not writing a custom exception for this. I'm going to import that class, which should be this one. Okay, so I expect that eating run without setting both numbers requires both numbers to work. Okay, should throw that exception, which I think they should pass, because yeah, indeed it throws the exception that we expect. Okay, all right, let's duplicate this test and say test class requires number one to work. My test naming is ridiculous, by the way, but it's okay. So before we hit run, we are going to now run this multiplier and add set second number, say to 2, for example. So we've indeed set the second number, but we have not set the first number. So we are running it before setting the first number. If I hit this, it should throw that exception, and this test should indeed pass. So we can then test for the next one. It's quite easy to write a lot of tests, but some of these are just redundant, to be fair, because if I'm already testing each of these, then I don't need to test for this. But I'm going to leave it in there because, again, this is just a tutorial. It's not like I'm going to do this in real life. All right, so I'm setting the first number now without setting the second number, and I'm hitting run, and that should work properly because, again, my test should pass. So I normally once in a while just run my entire test class. You can see that we've run our test class. We've written 4. Is that 4? Yeah, we've written 4 tests. Now we are currently, initially we are testing the instance, that the instance exists and all parameters are resolving properly. We're testing that both numbers are required. We're testing that each number is required separately, and we are testing that everything is working well. So our class is making good progress on this, and it's making some sense at the moment. Now there's a decision we need to make. We need to validate. We need to decide on what kind of operation we are going to be allowing. We don't want people to just be able to enter any kind of operation. Okay, so let's go back to our test and say public function test class requires specific type of operation. Okay, so how do we decide this? There's something, we can create a very simple array and say, yeah, in this array, if the operation you're asking me for is not in the array, then I'm going to fail it. We can do it in different ways, but I think, in my opinion, the easiest thing to do is to create an enum class, which I would be explaining thoroughly in the actual course. But for now, I'm just going to be creating the enum class and say operations. I'm going to create operations. I'm going to say this is an enum class, and it's going to be very easy. And this is going to be returning a string, by the way. I'm going to define the first case that I would be accepting would be add, obviously. Okay, my second case would be not edit, it would be multiply, apply, and say the string is going to be multiply. My third case is going to be divide. My next case is going to be modulus. I don't think I want that, modulus, which you should complete it, but I guess not. Okay, so let's say these are the operations I allow for now. What else is missing? I think there's something missing from this theory. There's add, multiply, divide, subtract. There we go. Subtract. So I have these operations enum now that would help me to definitely be able to check that this particular operation you're asking me for is a case defined in here. If it's not defined, then I cannot accept it as an operation. Okay, so let's go ahead to start this particular test now. Test case requires specific type of operation. Essentially, we want to make sure that people or whoever is going to be using this particular multiplier class cannot just try to use an operation that we do not support at the moment. So what we can do, and the good thing about using an enum in this way is that I don't know if you've missed any part of this, but I have a new method here that says set operation. I have set this to use a default operation that would allow my test to keep passing. And yeah, I think that's all. So moving back here now, I'm going to be expecting an exception, but it's not going to be an exception like I've been expecting before. This enum class itself has a way of handling these kind of things, and it throws an error. It's an exception, but it's an error type of exception, if that makes sense. All right, so I'm expecting an error to be thrown if somebody tries to use an unsupported enum, which, to be fair, I can catch that error and return a proper error message to them, but I'm just going to be making it this way for now. So let's say I have the multiplier. I'm saying set operation of this multiplier, which I don't even think I need to get to this point. I think I can start by creating a fake enum not instance case. Yeah, that's the point. Fake enum case would say, let's try and use our faker and say random text, I guess. Random text takes an array in it, and I can have my random text, which I'll make uppercase, fake2, and then say something like ops or something like that. And then I can now say fake enum, no, fake operation now, that'll be better. And then I can say operations that, by the way, I don't need this, not at the moment. So I don't need to run this. I expect this to throw an error because none of this exists in my operations enum. Hopefully that makes sense. When I open my operations enum, I have specific things that I expect to see in there, and none of this exists in the operations enum. The reason why I'm doing this is because I also want to make it a bit more flexible and say, okay, I'm not just testing for a specific string like fake or something like that, which I think would also fail, because that would, if I show you what I mean, if I do this would already throw an error here. I can't even do anything. Okay, so if I do want to test it, I have to do it in a certain way, which I've decided to go in this way. So if we run this, I expect it to pass, because again, none of this exists, and that's what we have here. It's passed. So we have essentially said that the operation you ask us to perform, the operation you have this multiplier to perform, has to be a part of our supported operations, which we can't have a supported, we can't have a snippet here, multiplier. By the way, we called it multiplier. I don't know why I called it multiplier anymore, because it does support other operations, multiplier operations, but I'll call it multiplier anyway. I don't know why I called it multiplier anymore. All right, moving on. I would probably have to change the name because this is just poor name for the class at this point. But let's run all our tests and make sure everything is still fine. Everything is still running well. We have 5 tests right now. All is still running well and everything is passing. If we do want to test that our test cases are working properly, we can remove this, and we expect at least 2 of our test cases to fail. And how many failed? Oh, all of them failed. Wow. Yeah, that's effective. That's very good. It means if somebody else works on this and makes some changes that is not supposed to be made, that is not supposed to be accepted, we expect that they are going to see it when they run the test. And this is another advantage of really writing as many tests as possible. I think having redundant tests like I have somewhere here is better than having little tests, or having some less coverage of your test. If you have too many coverage, which I think doesn't make any sense, but it's so much better. Let's move this up here. It's so much better than having too little coverage. All right, let's run this and see what our coverage for this particular class is now at this point. Okay, let's replace active and see what our coverage is. So if we go to services multiplier, at the moment we are at 78% coverage. I don't know what is missing, but let's see. Set operation is missing, so let's make sure we cover that also. And yeah, that's it. So we've not tested this particular method. Let's go back and test us. This is where we write test so that we can cover as many things as possible and make sure nothing is somehow my okay, there we go. Okay, so let's cover that so that we can have 100% coverage at this point. So test set operation works as expected. Okay, let's use the multiplier instance, call set operation, and set not a fake operation this time, and set operations multiply, and then now we need to do, let's say assert equals this multiply get operations. Very good. PHP Storm can be very helpful in this case. Expected. There we go. So now we need a method. If I run this test, it's going to definitely fail, which is expected because there's something missing. We don't have a get operations method. So if I go back to my multiplier class, which I think is on this side. By the way, we can't close this now. We don't need that anymore. We have added a new test that would cover this particular one that we've been told is missing. But now that has also shown a flaw in our system because there's no way to get operation. And then we return that, which essentially means we also need to have a public function get first number, right? Return the first number. And then we need get second number, which returns the second number. And now we have more tests to write because we would now have 2 more methods that are not covered in our test. By the way, this test now passes because our get operations work properly. But I'm going to run the coverage again just so you can see that we have more tests to write. Because again, let's replace the active one and go to services multiplier. And now you see we have 80%. We have because we are not covering these 2 guys. So let's cover those 2 just to make sure everything is fine. Let's say public function test. Test set operations works as expected. No, not operation. Set first number. First number works. Just pardon my typos. Works as expected. Okay, let's do that. Set first number to that. Make sure it gets us what we want. It's very easy to do. Let's also do this and set second number. Second number, set it to 2 also, and get second number. So these 2 should pass now, hopefully, but I'm going to just run with the coverage. I think it will pass. Nothing is failing, and then let's replace, and I think we have 100% coverage of our, see, we have 100% coverage now, which is what I would always want to have. But most companies would prefer to have at least 70% or 80% coverage test, which would be acceptable for most companies. All right, cool. So we've been making progress on this. We have our first, we have a very stable class now that has been tested thoroughly. We know everything is covered. We know if somebody wants to use this class, this is what we expect them to do. We have made it in such a way that anyone that wants to consume this class, it becomes quite easy for you to know what we expect from you, and you know what to expect from us. And that part has not been defined, to be fair. We've not really defined what they should expect from us. So I'm going to start doing that now. So let's imagine when this operation is done, what do we expect to return back to user? Normally, we could just do this and return like an array of some sort and say, okay, let's return this array and say first number is this, second number is that, and this and this and this, which would work. But I would always prefer to have a class that would undo this. By the way, Laravel has a way of handling this, which is quite effective. But again, this is a tutorial I'm going to be teaching you or just showing you how to create those result class. So I'm going to create a new folder just to have I'm going to call it results. In that, I'm going to create a new class. I'm going to call it response, multiplier response, and that should be fine. If my spelling is correct, I'm going to copy that and then create that class. So I expect my multiplier response to be a publicly available float, right? Because remember, which obviously can be no, we are accepting first number Oh, I called the number 1 over there, so let's just call it number 1 here and duplicate that 1 2 and then operation public operations. Remember, we have that now, operation, which I think I need to fix this, right? And then import this. Cool. And then lastly, I will now have, I think it's going to be a float also, which is going to be results. So every time I return back my response, I expect to have this. Okay, so now my multiplier class is going to always return multiplier response, and I can then say returns new multiplier response. What's going on? Undefined returns. Oh, sorry, return, not returns. Okay, so this is easy. We have said every time I run an operation, I expect to return this if all my parameters are correct. If it's not correct, I'm going to throw an exception. And by the way, this might not be necessary if we don't have this here. So if we didn't allow null here, then I wouldn't need to check here, because the constructor would already throw an exception that these two are required. Remember, we saw that earlier. If you don't remember, you can just check that particular part of the video. But I decided to do this here because we do want to test that the instance can be instantiated on its own without having to set the parameters that we require for this particular class. All right, let's go ahead and see what we need to cover here. Obviously, we do not have this covered in our test. We also do not have any test coverage for this itself. Okay, let's just start by doing that now. Let's say public function test run returns multiplier, if I can spell, multiplier response object or something, multiplier response object. Okay, just again, pardon on my typos. Hopefully I can do some editing to make this a bit more bearable for you. Okay, let's say I've set that operation, set the first number, set the second number, and I'm running it. Now I expect my instance to be multiplier response. I expect my result to always be multiplier response. It shouldn't matter what the value of, I have to add that in there. Shouldn't matter what the number I'm result is. It should always return this instance. This would pass now, and it would fail if I'm returning, for example, array here. So if I run this, if I run that now, I expect at least 1 to fail, which again is failing because the instance must be this. What we have done is to now say, okay, I want to always return this. Let's do that. Okay, obviously we still need to test that the actual thing that is returned has the correct things inside, but at this instance we've at least made sure that our run method would always return the correct instance that we expect from this operation. Okay, so let's go ahead one more step. Let's run this again to make sure everything is still passing. Cool. One more step. How do we populate this? We could populate this easily by doing something like, okay, response and say new that, and now do it individually and say number 1 is this, number 2 is that, operation response operation is that. Oh wait, is something wrong with my spelling for operation? Oh, it's plural. It should be singular. I don't know why I made it plural. It should be singular because we do expect a singular operation for that. Okay, which is fine now. And then I can now say response results to be equal to yeah, I'm going to show you something else here, but for now I'm just going to be doing this times this. For now I'm just going to be doing that. So we could wait, what's going on? It says what? Local object is used only, right? That's fine. So we can now return a response back. That's what it's trying to say, that we've not used. So this will be fine. all of my tests should still pass. And in fact, if I do want to do a bit more testing here, I can say public function test run returns correct values. Okay, and I can copy all of this and do a bit more thorough testing here. My operation is multiply, and I need to add that in there. I'm testing the instance here, which I can decide not to test anymore. I can now say this assert equals this operation get up. No, that's not what I want to do. Let's remove that. So I expect the response from my results, the operation from my results, to be the same as the operation that I have set here, which, by the way, I can use the multiply operation. I can say this get operation. There we go. Now I can test for first number, or did I call it number one? Yeah, I called number one to be equal to get first number, and I can do it for second number and say get second number. This is not set, this should be get first number. There we go. So what I'm testing for now is I have set all of these things that I need. I've run, or I'm running the operation, I'm getting the result. I know the result is supposed to be a multiplier response object, which it is, and I am now asserting that the values inside the response object matches what I expect to see, and the last value I need to check will be the result. So assert equals, I don't need all of this sometimes, result to be equal to result, and I expect to see, what's my value? I expect to see 4 here. Okay, because 2 times 2 is 4, obviously. So if I run this, I expect it to pass. Hopefully passes. It does pass. Now I don't need this anymore because it's definitely redundant. Okay, I should still have 100% coverage, but just to be sure, let's test it out. Run with coverage and see what coverage I have at the moment. It's still 100%. So I didn't need that particular test. And in fact, I'll show you now why I believe this is redundant. If I remove this particular test here, I should still have 100% coverage. So let's do that. That's how you know when something is definitely redundant, if you still have 100% coverage. So there's no point in having that particular test in there. Right, so we still have 100% coverage. Everything is still good. We have our operation working properly. What is wrong with this? Flip comparison, that's fine. Okay, so our class is working properly. We are getting the operation. But instead of doing this, I'm going to comment this out, and I'm going to be returning a new multiply object. And now in here, I'm going to set a constructor, okay, and I'm going to move all of this. It makes so much sense to do this instead of what I've done earlier. I'm going to move all of this and say, right, and I think I messed up my tab somewhere. So if I do this, I can now, where is it? Go back to my multiplier and just essentially do, let's copy, that would be this, num1, this, number 2, this operation, and then the result is going to be, obviously, the result is going to be this times this. Okay, so just to make things clear, I'm going to say num1, nope. Let me show you how to define that. Okay, number 2. This is so that whoever is going to be using this class knows definitely operation, and then results. Yeah, it just makes it so. This is the same thing as this, but this looks better, right? We can both agree on that. I'm going to delete this, and if my test still passes, everything is good. This is another advantage of writing test. I can refactor my code with confidence. Do you understand? Now I've refactored this, and I'm confident that everything is still fine because all of my tests is still passing. And I don't really need to test this somewhere or use the class or something. I can just confidently refactor my code. So if somebody joins say for example, we have a PHP 8.9 or something, and it has some very useful methods, inbuilt methods that could allow me to do some of these things quite easily. and I refactor my code to be 8.9 compatible, I can just run my test because I do have 100% coverage. If anything fails in my test, I then know that I've made an error, and whoever is using my class anywhere else will have trouble, and I can fix those problems and fix the test, and then I can confidently say that I have done a good job on that. Okay, so all my tests is still passing, and as you can see, it's still 100% coverage, which is very good. So let's now do the actual operation, which is what we've been trying to do all along. Okay, now we have enum class defined. But how do we convert the string that this enum class returns into something that we can then use to actually do operations? Okay, let's go and I don't need to write any more tests, to be fair, because this is already testing that the operation works as I expect. We might need to test other operations because this is just testing multiply. We might need to test other operations, but for now I'm going to leave the test, and I'm going to come back to writing some more tests once I add some more methods in here. So the method that I want to add now is a way for me to determine the operator to apply to these two numbers depending on the operation that has been defined by the user. So how do we do that? I've not thought about this already, but I think we can figure it out. One thing we can do is to have like an helper method somewhere, or an helper class, and say, let's say a class operations helper. Again, there is probably a much simpler way to do this. For example, I can add let me show you what I mean. I'll create this class first. Okay, in my enum I can add a method here that says something like function from name, and I will take the name of it will be a string, obviously. Say name, I don't know what to call it, and then I can return like a switch, a match would even be much better. I can say if my name matches this, I can return, plus or something like that. Do you understand what I'm trying to do here? Multiply, divide. In fact, you know what, I'm going to just put this here, so when I push this into, and I can also have where's modulus, which I don't think I'll ever use for this example, but anyway, and I can do this here. Okay, we need to have a comma here, and then we have a default which is invalid, throws an exception, invalid exception, nope, invalid, come on, invalid operation. I can put a comma here, and I can close this, and I can import exception in here. Oh, I don't have any exception, so let's just, oh sorry, I need to throw new exception. That's the problem. Cool, and I can import that in. So I can have this, which would allow me to, from my multiplier class, I can now say something like operation from name, and just put the name of the operation here. Do you understand? So I can do that, but I'm not going to be doing that. So I can do that, but you know what, let's just do it, right? Let's do it. Let's just say here, I'm going to say operations from name, oh, that already comes with, nice, that's very nice. Operations, I think, oh, I can't do that. Okay, wait, let's go back to operations, public static function. Let's see if that would help me, and say, there we go, from name, this, operations, value. Should it be value, or should it be this? What does it take? Oh, it shouldn't be a string. I'll just put name there. Go back to multiplier. What is going on? Expect string, that's fine. I'll then put the value in there. Right, so I found the problem. Thank you for your patience. This error is actually because This is expecting to see an operator, but that's not what we want. We do want an operator here, not an operation. So it should be string, and it should be operator, not the operation. Okay, so that should fix that error, and it's now going to be operator. Now what we are doing is we're getting the operation that was defined by the user. We are putting that in here. We're getting the value of that operation, which is essentially going to be a string. So the operation that they've defined, for example, in our test, this multiply is going to have a value of multiply the string. Okay, so what we are doing here is to say this operation that has been defined by the user, get the value, which is going to be a string, send that string back to the operations enum, and make the operation from the name. So that's what we have done. Let's put the thing here. I just don't like seeing all those lines there. Okay, so this should pass. I don't anticipate any problems here. Oh, it fails. Nice. That's very good to see. Okay, so this should be fine. Let's see what is failing. It says this is failing because get operation expect to return undefined property operation. Right. See, we made some changes somewhere that has now led us to. Wait, why is that not defined? Let's figure it out. Multiplier response. Oh, I see. That's the problem. So multiplier response doesn't have operation anymore. It has operator, which now is a string. So we need to get the value of this to be able to compare those two. All right, cool. Let's see. It's still failing. Figure out why it's failing now. Right. See. So this is fine. This is what we do expect to see. But I'm going to get the name then instead of that. Let's see if that works. Yeah, the name is still multiply, even though this operator is that. Right, so I don't think we can. You know what? We can't say from. Yeah, we can't do that. It's ridiculous, but there's a much easier and nicer way to do this. But I am going to be sticking with what I've started already. So we're going to be copying what we have here, essentially, and comparing it with this, which is quite redundant, to be fair. But and then multiplier get operator. Okay, get operator, and now we're going to use the value here. Value, not the name. I think they should pass now, but yeah, that's fine now. Okay, it's maybe redundant. It's probably useless to do this, but our test is passing. I'm going to leave it that way for now. All right, so what we are doing now is we are taking the operations enum and getting the correct operation to apply, which is either of these guys, in this thing here. Okay, so let's go back in here. We could actually add a method here and say public. It could be private, actually, to be fair. Private. Should it be private? Should it be here? I think this is just the response object, so let's not put it here. Let's not do any calculations here. Let's just come and do it in our class itself. So instead of doing this, we're going to be having a method that says apply operations. Okay, or play operator. Apply operator. Let's create a private method here that says apply operator, and that's going to be returning this number one, this operator, which is going to be this guy. We need to refactor that, and then this number two. And at the moment, I don't know how to. Oh, right. Because this is a string. I don't know how to convert this string into an operation. I'm going to pause and fix that and then come back to tutorial. Return batch operator and say if operator is plus, just do that, plus this. It's quite I don't know, this is not what I wanted to do, but I think it's fine to do this for now. I think we do have a modulus, and I'm We have a divide also. That should be divide, not modulus. We have a modulus, which should be, oh wait, do we have anything like this? I have no idea, but I'm going to leave it there. Right, what's the problem here? It's a duplicate of what? Oh wait, there's no duplicate there. I don't know what is going on. Oh right, duplicate of default. That's fine. We do have our default to be hard, by the way, so let's just make it that. Let's merge it. I think merging it is better. Cool. So that should be fine. We're getting the operation from value. We need to add that up there. We need to also return floats, null, or int. You know what? I don't need all of this. I'm going to just make it float or null. Okay. Let's see if our test still passes now. And it does pass. Yeah, cool. So we have apply operators now, which, by the way, I was going to make this into its own class, but I changed my mind on doing that. We could have it as a class on its own that then can do a lot more complex operations and so on and so forth, but I don't think we need that at this point in this tutorial, which is a predicament of people like me. When we record tutorials, we tend to sometimes overcomplicate things. I'm going to delete that so you don't have to worry about it. So our test passes, everything seems fine. We're applying the operation as expected. So let's run the test and check the coverage. I'm sure we have less coverage now. And then we would then, let's see how many. Yeah, I'm sure we have less coverage. So cool. Let's see what we have. Because we have also not tested some of the other operations. So here we've not tested minus, we've not tested divide, we've not tested modulus. We have essentially just tested plus and multiply. So we just need to add those instances there to make sure everything is working well. Cool. Let's go back here, and now I'm going to show you one more very fancy way to do this. Okay, let's say this might become redundant, by the way, but I'm going to leave it in for now. So public function test run uses correct operation operator and returns correct results. Okay, we are going to be using something called data generator. So public function data operation data. I use that kind of name, but I wouldn't do that in this tutorial. So data operations, I'm going to be returning a generator. Oh, my bad. Generator, and I'm going to be using yield. If you don't understand what this is, I apologize, but it's just essentially a way to define things. Operator, I expect my operator to be multiply. No, sorry, my operation to be multiply. I expect my operator to be this, and I expect first number, let's just say first so it's easier to see. If I put 2 in there and my second is also 2, I expect, if my operation is multiply, I expect the result to be 4. Correct? Yeah, correct. So this defines everything that we need to run this test. Okay, I am going to copy this test over and put it down here. Okay, now this guy expects to use, we have a new way of defining this now, which I really like, data provider, and it's going to be data, I think it's supposed to be a string, data, there we go, operator. So this data is now connected to this test, which means this test would expect me to have some parameters in there. The first parameter is likely going to be my operator, which, thank you PHP stop. The second will be first, second, results, and I think I do have operation here, right? Let's put operation there. So operation, yeah, cool. So I can then change this to be first number, which, why am I saying first number? It should be just first, second, and make this first, make this second, and I need to add that up there, and my operation would just be, oh right, yeah, it's fine. My operation will be operation, oh, which I defined as string. It shouldn't be a string. There we go. And then my result will still be my result, which okay, results, let's change this to say result from run, and then this will be expected results. Okay, so we expect the expected result, we expect result from run, excuse me, we expect the result from run to be an instance of this. We expect the result from run, I'm going to change all of this, right, to be result from run, right, and we expect this to be equal to this. Cool. I think we are in a good place to run this test again. Let's run it and see what happens. Okay, so you see this particular test that we have written, I didn't use operator. Okay, let's test the operator. Do we need to test the operator? It's okay, we don't need to test the operator. So I can take this out. We could test the operator and say it's returning the correct operator, but if the result is correct, then the operator is correct, which might not always be true because plus and multiply can be equal at some times. But again, I'm not going to be overthinking it. I'm going to just be leaving things as simple as I can. I think I've already complicated things enough. But this test is the same thing as what we have here. The difference is that now I can create multiple instances and use add, and then say divide, and I expect this to be 1, right? And I can say what else do I have? So I have add, multiply, modulus. I don't even know what to expect with this modulus thing. I think it's going to be 1 anyway. No, 0. There's no reminder. 0. And I can actually also label this, but I'm not going to label at the moment. Let's run this test and make sure everything is fine. Run this test. I expect, did it fail? Oh, right, sorry, there's a problem. Right, I do need to label it because it's not going to be able to run it if I don't label it. So we're going to be saying yield operator is add. Put that in there and then do it this. Yield operator is, oh, this is multiply, sorry. Multiply, add, and this is divide, and this is modulus. I think that should be fine now. So if you run this test, you would see that oh, there's an error. It says the data provider specified for this is invalid. It's non-static. Sorry, my bad. This should be public static function. There we go. Now that should be valid. Okay, cool. Let's run this. Right, so now you see we have with data set operator is multiply. You know what? This, yeah, it's fine. Let's see what the problem is. It says that unknown parameter result. Cool. Let's see. Oh, my bad. It's expected results. And I can copy this and change all this at the same time. Okay, now what else? Where else can we? So expected results shouldn't be a string though. It's a float, I think. It should be a float. Let's run this again. Still failing. Oh, just one is failing now. Oh, everything is still failing. Cool. It says that argument 2, this must be of type string, int provided. That's the problem. So this should be float. This should be float. Okay. Run that again. And that passes now. So this single test is now considered 4 different tests because we have a data provider. See, so we are using all these data sets to run different instances, different versions of this same thing. We could add more. We could say, okay, let's see what happens if I actually use if I use an actual float, so I can say multiply with float, and this would be with string with int. You know, this is really not that important, but you know, I expect 4.4. If I run this particular instance, it should pass. Oh, it fails. Nice. It's 4. Sorry, my calculation is wrong. My math is not that good. Why is it that though? I have no idea. Oh, that's multiply, not hard. My bad. Okay, cool. It's multiply, is not hard. That should pass now. Yeah, so essentially, if I run all my test suite, everything passes. I have so many tests. I have 13 tests and 37 assertions for this single class. Okay, let's test if my coverage is now 100% again. If it's not, we can write whatever is missing. Let's see what the coverage is. Fingers crossed. Ooh, 97%. Let's see what's missing. It's in the multiplier class itself, and we've not tested minus. Did we not? That's odd. Oh, we did not. Okay, instead of adding this redundant one, I can't just add a minus somewhere here. Copy this and add a subtract. Make this subtract, and I expect to see 0. I don't want 0. I'll say 3 and 2. I expect to see 1. There is actually a problem. I'll show you what the problem is now. Let's run all this. 1 is failing. Yeah, obviously. So subtract is failing, invalid operation, because I didn't set the operation to be. Oh, I don't have subtract in. Yeah, that's the problem. I knew there was a problem somewhere. Subtract is not here, as you can see. So let's add subtract here. I don't know what subtract did to me. I've been missing it out since. Let's see if we have it in here also. We do have it in here. All right, let's run that. And yeah, all passes now. Coverage should be 100%. Absolutely fine, 100%. So yeah, I think that's it. We have essentially been able to solve the problem we defined since the beginning. We have been able to return the result in a specific manner. We can now write a documentation and say my result would always be in this format. And yeah, I think that's the end of our tutorial for today. We have written the class that we need. We do have a multiplier response object which doesn't need this. We went through a couple of problems, but I think we eventually solved it. We've been able to practice the concept of writing tests before we write the actual code, and also making sure we have a full coverage for our test. Now, even though we have a full coverage, there are a couple of things we've not tested for. For example, do we want to be able to return negative numbers? Do we want to be able to return only positive numbers? And so many things we could be testing for. Another thing we can do in our multiplier class is to make this accept more numbers. So essentially this could become an array of numbers, and then we apply the operation to each of the members of the array, etc. But I'll leave that up to you to expand as you like. But the main purpose of this tutorial has been achieved. We've been able to write 14 tests, 42 assertions for a single class. So in a full project you would have a lot of tests. Okay, and I think that's the end of this. Thank you so much. Don't forget, if you want to go deeper into any of this part, you can get the course in the link provided, hopefully in the description of this video. Thank you.